practice you're going to do today on Friday deals with slope of a line, but we're going to look at it in terms of rate of change. In other words, looking at something changing over a certain amount of time, or in some way something's changing. And there's a really important point to be made here, that all graphs tell a story. So I'm going to take a little bit of time with each graph and talk about the story that the graph's telling. This was really important, a really important skill for me to have when I was an engineer. I was a field service engineer repairing semiconductor equipment, multi-million-dollar pieces of machinery, and I needed to figure out when they broke, why they broke. And I would almost always go to a graph first. I would pull up a graph on the equipment, and the graph told me a story. And if you're able to interpret graphs, that's not it's not that hard once you understand how to do it and become comfortable with it, but it's extremely important to be able to do. And I was good at that, and so that made my job that much easier, and added a lot of value to the service I was providing as an engineer. So this is a pretty important thing to understand. Anytime you see a graph, you should read all of the labels. Here we have the distance traveled. That's the title of the graph. And I see that on the y-axis, it's distance in miles. And on the x-axis, it's time in hours. Many line graphs will have time as the x-axis label, because time is most often, although not always, but most often what we call the independent variable. And what's graphed on the y-axis will be the dependent variable. And if you remember that we said x and y on a function is like the input and output, this will help you understand independent variable and dependent variable, because the output y depends on the input. In other words, if you're traveling in a car, the distance that you travel depends on how long you've been traveling. So you choose a certain amount of time, like 1 hour, you've traveled. It's hard to tell exactly what that is, but it's less than 50 miles, maybe 45 miles or 40 miles. So in 1 hour, you travel, actually I can tell exactly what it is, yeah, 40 miles. So the distance that you travel in miles depends on how long you've been traveling. All right. The only difference between this and what we've done for slope, what we did for slope earlier this week, is that we just have units, which we've already dealt with this when we did our proportional reasoning unit. We wrote ratios. Remember, slope is just the ratio of the change in y over the change in x. The only difference here is we've got units to go with the numbers. The other slightly tricky part about this is you saw me a moment ago struggling to decide whether this was 40 or 45. And so you really don't want a point like this. I know this point is exactly 1 hour, but I don't know exactly how many miles. But I looked up here and I used this point, because this point on the line intersects at a known x value and a known y value. And so that's why that's a good point to use, one where I know x and y for sure. The other good point to use as you scan through these points would be the origin. The origin is the other one where I know x and y. X is 0 and y is 0. And so if I'm moving from, I'll label them, but you don't have to label them. But if I'm moving from point A to point B, the change in y, I'm moving up. Now earlier this week, we would have said the change in y was 1, 2, 3, 4. I move up 4. But because we now have units, or we now have a scale on our axis, those 4 units up represent 200 miles. I went from 0 miles to 200 miles. And I went up, so that's positive 200. So the change in y is 200 miles. From there, I need to move 1, 2, 3, 4, 5 to the right. And each one of these is 1 hour. And so that is, in fact, plus 5. But it's positive 5 hours. And then to get the answer, the rate of change, you just do 200 divided by 5 is 40. and then you look at your units, it's miles over hours. And we talked about earlier this year, we said the vinculum indicates division, and division can also be represented with the word per. So it's 40 miles per hour. That's a unit rate. You can connect this back to when we did unit rate. If you go 200 miles in 5 hours, on average you go 40 miles in 1 hour, 40 miles per hour. and because we have choices down here, we should look to see if we find this answer. And right here I see 40 miles per hour. Let me read the directions. Find the rate of change represented by each line. Some answers are rounded. Cross out the letters above each correct answer. Okay, so we found 40 miles per hour, so I'm going to cross out the S. This is another one of those puzzles where after we do them all, the letters that remain will answer the riddle. What does it take to win a tug of war? Here's my method for this one. I'm going to do the first. If you look at your practice sheet, you see 9 graphs, 6 on the first page, 3 on the last page. Some of them have 2 lines. None of them have more than, yeah, some of them have 2 lines. I'm gonna put the short video for the first 3 before the slide for the first 3. And then I'm going to put the video for 4 through 9 after the slide. So at some point you try, right now you should be doing them with me and learning how to do them. And then at that point where you see a slide where there is not a video yet, you try that one on your own, and then you watch the video to check your solution or to get some help. All right, so let's look at the next one.